All right, Emma, what's prime factorization of 9? 3 to the second power. Correct. Okay, what's the prime factorization of 24, Nikki? You got it yet? 2 to what? 2 to the third times 3? Yeah. 2 to the third times 3. All right, now, to find the LCM, okay, step 1 is do what you just did. Prime factor the numbers. Obviously using either inverted division or factor tree. Don't care. We're just trying to get to the prime factorization. Step 2, list each prime number, prime factor that was used in either prime factorization. Okay, that's step 2. So what were the prime factors used in this prime factor in either prime factorization? 3 and 2. So 2 and 3. So this is step 2. This is step 1. Okay, step 3. Find the greatest exponent or power of each prime factor in step 2. So I have 2 times 3. So step 3, I have 3 to the second, 3 to the first. Which is the greatest power, 3 to the second or 3 to the first? 3 to the first is greater than 3 to the second? 3 to the second. We're using the highest power of each prime factor. Here I have 2 to the third and no 2. So which is greatest? 2 to the third. So I use it 2 to the third. Now I'm going to take step 4, multiply the prime factorization from step 3. So I take 2 times 2 times 2 times 3 times 3. 2 times 2 is 4 times 2 is 8. So that equals 8 times 3 times 3. 8 times 3, 24. 24 times 3, 72. So that is the LCM of 9 and 24. Okay, that's the least common multiple of 9 and 24. In other words, if I was to count by 9s and I was to count by 24, so 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and I was to count by 24, 24, 48, 72, 96. The first multiple that you will run into is 72. Okay? Where people make their mistakes here, they get factors and multiples confused. Okay? Factors are numbers that you multiply together to get a certain product. Multiples are the products. It's counting by a number. Multiples of 5 would be 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and so forth. Okay? Nick?
So what we just did to find 72, we can do that instead of listing all of them.
Yeah, I don't want you to list them. I want you to use the prime factorization. Do not list the multiples. Okay? Don't list the multiples. Use the prime factorization. The reason we got to know what the prime factorization is we look at this next number. These next sets of numbers, 30 and 33. We want to find the LCM of 30 and 33. So if we prime factor 30, 2, 15, 2, 3, 5. 33, 3, 11. So the prime factorization is 2 times 3 times 5 and 3 times 11. So that's step 1. Okay? Step 2 says to list all prime factors that were used in the prime factorizations. So what prime factors were used? Okay? 2, 3, 5, and 11. Okay, so once again, this is step 1, step 2, step 3 is we find the greatest power of each one. So I have 2 times 3 times 5 times 11. I have 2 to the first, no 2. So I got to use 2 to the first. Okay, I have 3 to the first and 3 to the first, so I got to use 3 to the first. You will notice I did not use 3 to the second. I am not putting exponents together. Okay, then I have 5 to the first, no 5, so I got to use 5 to the first. Then I have 11 to the first, no 11, so I got to use 11 to the first. Okay. Step 4 is actually multiplying it out. 2 times 3 is 6, times 5 times 11. 6 times 5 is 30, times 11. 11 times 30, 330. And that is the LCM. Okay. Now, it doesn't change if you have 3 numbers, 9, 14, 21. And we want to know the LCM of those 3 numbers. Okay, well those prime factorizations are easy. What's the prime factorization of 9? 3 to the second. Prime factorization of 14? 2 times 7. Prime factorization of 21? 3 times 7. So there's your prime factorizations. That's step 1. Step 2, list all the prime factors that was used. What prime factors were used? 2, 3, and 7. Next one is to find the highest power or the greatest exponent of each prime factor. So I have 2 to the first, no 2, no 2. So I use 2 to the first. I have 3 to the second, 3 to the first, no 3. So I use 3 to the second. I have 7 to the first, 7 to the first, no 7. So I use 7 to the first. Now I multiply. 2 times 9 times 7. 2 times 9 is 18 times 7. 18 times 7 is 126. and that's the LCM. All right, now, I want you to do this one on your own. LCM of 34 and 52. All right. Who has an answer? 2 people? 3 people? Nikki, what'd you get? What? 884? That is correct. All right, now, make sure we know how we got it. Prime factor 34. 2 times 17, prime factor 52. 2, 26, 2, 13. Okay, so I have 2 times 17, 2 to the second times 13. Okay, so we use 2, 13, 17. I have 2 to the first, 2 to the second, so I have to use 2 to the second. I have 13 to the first, no 13, so I got to use 13 to the first. I have 17 to the first, no 17, so I use 17 to the first. So that's 4 times 13 times 17. That's 52 times 17. 52 times 17 is 884. And that's the LCM. All right, let's look at this one. 27 and 48. And I want the LCM. Okay. So what is the prime factorization of 27? 3 to the third power. What is the prime factorization of 48? Hang on. Raise your hand. Emma? No. No. That'd be 42. Celine? No. Drew? 2 times what? No. Got to be prime numbers. Nick? No. That would be 24. Grant? No. That would be 72. Sophia? Yes. 2 to the 4th times 3. Remember, 48, 2, 24, 2, 12, 2, 6, 2, 3. What do you say? Is he making fun of you?
I told her we don't do that here.
Yeah. All right. So 2 to the 4th times 3. Noah, shut the door for me, please. All right. So we have 2 times 3 are the prime numbers that are used. Okay. The greatest power of 3, you have 3 to the third, 3 to the first, so we've got to use 3 to the third. I have 2 to the 4th, no 2, so I've got to use 2 to the 4th. Okay, I know that 2 to the 4th is 16, times 3 to the third is 27. So I'm going 16 times 27, 432. So the LCM is 432. All right, now, I want to find the GCF and LCM of these two numbers. Okay? So the process for the first part is still the same. Prime factor 90. That would be 3, 30, 3, 10, 2, 5. So remember, when we're doing greatest common factor, we need to list out the prime factorization. Okay, you don't want it in exponents because of the way you have to do greatest common factor. 165 is 3, what is that? No, hang on, 3, yeah, 3 goes into it. Be 55. No, 53. Yeah, no. Yeah, it's 55. Then you got 5 and 11. Okay? So I have 3 times 5 times 11. Okay, now I have to list for GCF. Remember, there's a difference. For GCF, we list all the prime factors that are shared. Okay? So, as we look at these, I have a 3 that's shared. I have a 5 that is shared. And that is it. So that means 3 times 5. Now, 3 is shared 1 time. 5 is shared 1 time. So 15 is the GCF. Now, I'm going to relist my prime factorization of the two numbers for LCM. Okay, so for LCM, we list all the prime factors that were used in each prime factorization. Okay, so the prime numbers that were used in the prime factorization is 2, 3, 5, and 11. Now, I have 2 to the first and no 2, so I use 2 to the first. I have 3 to the second, 3 to the first, so I use 3 to the second. I have 5 to the first, 5 to the first, so I use 5 to the first. I have 11 to the first, no 11, so I use 11 to the first. So I have 2 times 9 times 5 times 11. 2 times 9, we're going to go. I'm going to go 2 times 5, which is 10 times 9 times 11. I'm going to go 10 times 11, which is 110 times 9. 110 times 9 is 990. I'm not laughing. So, your LCM is 990, GCF is 15. So those are the two different ways that you must come up with GCF and LCM. You've got to keep the two ways separate. Okay, because obviously with the 15, you've got to be able to divide 15 into 90 and 15 into 165. Okay? For the LCM, you would count by 15s, 15, 30, 45, 60, 75, so on and so forth, all the way up to 990. With 165, obviously 165, and then you'd have to have you'd have 165, then you'd have 330, then you'd have 495, and that would be up to 990. Obviously, you wouldn't want to do that. Okay? So you got to keep the two ways and know what the two things stand for. Remember, this is multiples. This is factors. Okay, you got to keep the two things straight. Keep them separate. All right? So your homework. Homework is 4.4, 6 through 9, 11, and then 16 through 32.